Today we are going to start a new chapter, which is wave optics. As the name suggests, in this chapter we are going to deal with optics. What is optics? Light, right? Study of light. Now, so wave theory of light means we are going to deal with how the light is being propagated in a space. Earlier, we had different types of conception about the propagation of light. Anyway, light carries energy, that is for sure, because from sun, this is how we are receiving energy. Energy from the sun, from nuclear fusion, it is received at the surface of earth through energy propagation done in the form of light. These are radiations. So these radiations carries energy. Okay, now how these radiations are sent, or how these oscillations, I have drawn the oscillation, or I have drawn the light ray in the form of wave, right? Now how these waves are sent from a source. So this was a biggest confusion in physics. So first concept was given by Newton. Okay, so Newton has told that light is sent from a source in straight line and like a bullet traveling in a space. So when we are shooting a bullet, what will happen? Bullet will have a straight line motion, right? Motion under straight line, so that would be carrying the energy in the bullet, and that is sent from the source to different place. So this was the concept that Newton has given about the transmission of light. But this was not able to justify the reason for refraction, reflection. That is, first thing is angle of reflection, angle of incidence is equal to angle of reflection. Okay, with this concept we can't prove this. Next thing is the phenomenon of bending the light as it moves from one medium to another medium. Next thing is interference pattern that we will see. So like when two light rays superimpose at one place, there would be different pattern formed. Next thing is diffraction, that is bending of the light around a sharp corner. So with this concept, that light being sent in the form of bullet, or light being sent from a source like a bullet travel in a media, is not satisfactory to explain all this process. Now, Huygens has given the most satisfying or the most acceptable method of propagation of light through a media. So we know that the light carries energy. So first I will give you an example of water filled in a big tank. The moment we are dropping any stone, any element, the moment we are making a disturbance at any point, so just like dropping a stone at this point, so what will happen? This is a point of disturbance, right? From here we can see the waves are sent around it. This you might have seen at different places. In a pond, the moment I am dropping a stone, the waves are being sent. It's not sent in straight line, right? So one circle would be there, around that another circle would be there, next circle, next circle. So across that, so that is a two-dimensional figure, right? A pond, surface of the pond is a two-dimensional figure, and in that two-dimension, wave is being propagated, right, around it. Now Huygens has told that the light is also being propagated in the similar way. We will see Huygens wave theory in detail in coming lectures, but I will tell you in this lecture how the light is being propagated. So we have a source. So source is taken as a point of disturbance, like dropping a stone in a pond. So these disturbances are sent around the source three-dimensionally. So let's say this is the disturbance. Okay, so this is not the ray at this moment, actually those are rays, but I will see, we will take ray in a straight line, but I have marked different waves here. These waves are being propagated from this. But as we see in a water surface, the moment we drop a stone, we have disturbances in this way, right? Similarly, light will also be forming disturbances in this way. But how we will get things like this? These are called as wavefront. See, this is one wavefront, next wavefront, next wavefront. For example, the moment I am dropping a stone, so one wavefront will be generated. Wavefront means, see, the wave. So this wavefront would be propagated. Now this would be at this position next time. Okay, now this would be propagating two-dimensionally around it, and this would be the next position. So, see, instead of having a travel in straight line, what it is having, a wavefront is being propagated. See, initially it is here, now here, now here, now here. See, the wavefront is being propagated here. And next it would be here. Now, what is wavefront? So, wavefront, have you seen one thing, that whenever waves being propagated from propagated through surface of water, we can see that all the point in the wavefront will be on the same phase. I will tell you what is same phase. Let's say this is a wave. How to see this wave, you know? See, now the water, this is the top surface, right? This is the top surface, or I am looking the water surface that the wave is being propagated in this way. Now, if this is the top view, then take the side view. So, side view means, if this is the water filled in a tank, now the wave would be in this way. From here it would be propagated like this. From here it would be propagated like this. From the top, when I see, these all point would seems like a circle. This would also seems like a circle. This is the top point. Just visualize. This is the side view. Just take an example of water filled in a glass cup. The moment we are dropping any substance, we could see waves propagated in this way. But from the top, if you are seeing, that would look like this. Okay, like a whirlpool. So these are nothing but points in the same phase. For example, I have one wave in this way and I have next wave in this way. What is this phase? It is 0. What is this phase? Pi by 2. What is this phase? 180, which is pi. What is this phase? 3 pi by 2. What is this phase? 2 pi. See? These are the phase of a wave. So one complete wave represents 360 degree. One complete wave represents wavelength or 360 degree. So this is 180 and this is another 180. Total is 360 degree. Now next wave, what is this phase? 0. The top, see, this is crest and this is trough. So crest is having pi by 2 and this is again pi. This is 3 pi by 2. And this is 2 pi. Crest and trough. Now all the point, if I am joining, which are on the same phase of vibration, I will get a wavefront. I will repeat it. See, here in this picture, this is pi by 2. This is 0. This one is pi and this is 3 pi by 2 and this is 2 pi. So this is 0, pi by 2, pi, 3 pi by 2. So the whole thing will become a wave. So this is a wave. I will only mark pi by 2 and 3 pi by 2 here. These are representing my crest. Okay. So this is pi by 2, this is 3 pi by 2. Pi by 2, 3 pi by 2. Pi by 2 crest and 3 pi by 2 trough, extreme point. Pi by 2 crest and 3 pi by 2 trough. Pi by 2 crest, 3 pi by 2 trough. Pi by 2 crest, 3 pi by 2 trough. Now If I am joining all the points which are at the same phase of vibration, pi by 2, pi by 2, pi by 2, pi by 2, pi by 2 and pi by 2. This is a wavefront. Next wavefront I can obtain by joining all the waves, all the points which are at the same phase of vibration. So this is 3 pi by 2, 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 3 pi by 2. See, even that can be done for 2 pi. It is nothing like we can only draw it for 2 pi or pi by 2 or 0 pi or 3 pi by 2. We can draw it infinitely around the source of disturbance. Source of disturbance is nothing but the light source itself. Okay, so the condition should be very simple, that those points should have the same phase of vibration. Okay, once again I'll repeat: 0, pi by 2, pi and 3 pi by 2. These are different phases. Okay, the moment we are connecting all points are at the all points of pi by 2, we will get a wavefront. If you are collecting all the points of pi by 4, still you will be getting pi by 4. Where would be pi by 4? Here would be pi by 4. The moment we are collecting all pi by 4, we would be able to get a different wavefront. Pi by 2, a different wavefront. 50-degree angle, a different wavefront. So now we know that from a source, it is wavefront being propagated around it. So in the case of water, that would be this propagation would happen in a 2D plane, but here it would be around a 3D plane. So the moment I am switching on any power source, see, yeah, this is the power source. Now from here across this, so anyway propagation in this direction is not possible. So from here a wavefront is being propagated. 1, 2, 3, 4. Similarly, so a wavefront, like, see, just consider that, see, the entire thing is occupied by water. The moment we have a disturbance here, the wave is being propagated. So this is a point of disturbance. From here, this is wavefront. Okay, the wavefront means all the point in my hand are at the same phase of vibration. See, propagated. Now next, propagation. Next, propagation. So in this way, light is being propagated. So Newton has told that the light is propagated from a source like the bullet traveling in a medium, but here it is done through wavefront. Now, see, wavefront is propagated, but how we will get the direction of wavefront? Just draw a perpendicular to the wavefront. So this is the surface of the wavefront. Draw a perpendicular. This is the direction of wavefront, or this can also be termed as ray. So these are rays. Okay. Now we have the concept ray and wavefront. A ray is nothing but that shows the direction of propagation of wavefront. So wavefront is being propagated, but the direction of propagation is outward, from the source outward. Okay, so this is the direction of propagation. It's a very important concept. Now what is wavefront? Wavefront is a surface made of all particles at the same phase. Okay, during propagation of energy by method of oscillation. Okay, hope this concept is clear with you. Thank you.